Students, this is Kani's method, analysis of frames. The question is to analyze the frame using the Kani's method. So in the first step, we have to find out the fixed end moments, M bar AB, M bar BA, M bar BC, M bar CB and M bar BD as well as M bar DB. Then you have to find out the rotation factor. You have to consider the joint B, then consider the member BA, BC and BD. Then after getting the rotation factor and the fixed end moments, you have to enter that values into the Kani's table. That means you have to enter the fixed end moments like this and the rotation factor like this. Since the joint A, C and D are the fixed ends, that means there should not be any rotation contribution at these joints. So we have to consider the joint B. Then we have to find out the rotation contribution for BA, BC and BD. Then how will you find these rotation contributions? Then sum of the fixed end moments plus the far end contributions into rotation factor, that will give the rotation contribution. That means minus 24.5 plus 0 plus 0 plus 0. That value into minus 1 by 4 will be here, minus 1 by 8 will be here and minus 1 by 8 will be here. Okay. Then after that, do the iteration again. If it is same as the previous one, then we can stop the iteration. After getting this rotation contribution, we can find out the final moments and after that you can draw the SFD and BMD. Then consider this frame using the Kani's method. There is an overhanging portion of CF. After finding out the fixed end moment and the rotation factor, please enter all these values into the moment distribution, into the Kani's table. The value is 2 into 1.5, overhanging moment is 2 into 1.5, that is 3 kilonewton meter is the overhanging moment, but you have to enter here as minus 3. Okay. After entering this as the minus 3, but in the case of frame, you cannot consider this joint as a simply supported one. You have to consider this minus 3 to write the fixed end moment here. That means 20 minus 3, that is 17 here. Then after writing all these values, you have to find out the rotation contribution. This value plus far end contributions into the rotation contribution will give the rotation factor will give the rotation contributions. Then after that you can kind of find out the final end moments. Then next is sway analysis. In this frame, due to the asymmetry in loading, there is some sway. Then how will you do the sway analysis in the case of Kani's method? Then the first step you have to find out the fixed end moments. In the second step you have to find out the rotation factor. And the third step you have to find out the displacement factor. That displacement factor is only for the sway analysis. That means the sway will occur in the columns. That means the displacement factor will be for the vertical members AB and CD. Then how will you find out this displacement factor? The displacement factor will be obtained by minus 3 by 2 of the relative stiffness divided by total relative stiffness. Then what is the difference between the rotation factor and the displacement factor? And what are the difference between the distribution factor, rotation factor and the displacement factor? The distribution factor will be the ratio of the relative stiffness to the total relative stiffness. That value into minus half will give the rotation factor and that value into minus 3 by 2 will give the displacement factor. And the distribution factor is for the moment distribution method and the rotation factor is for the Kani's method for both sway and non-sway analysis, but the displacement factor is only for the sway analysis. Okay, then after getting the displacement factor, then we have to enter this displacement factor by side of each column like this. Then after that we have to find out, we have to start the rotation contribution. Then how will you get the rotation contribution? By incorporating this displacement factor. If there is If the non in the case of non-sway analysis, the rotation contribution will be obtained by the rotation contribution factor into the sum of the fixed end moments plus sum of the far end moments. But in the case of sway analysis, the rotation contribution will be obtained by by the rotation contribution factor into the sum of the fixed end moments plus sum of the far end contributions plus the displacement contribution of that particular column. Then how will you get the displacement contribution of the particular column? That will be is equal to the displacement contribution will be obtained by the displacement factor into the rotation contribution of that particular column. The sum of the rotation contributions of that particular column plus if there is any story moment. If there is any story moment, then how will you calculate the story moment? In the second problem, there is some 50 kilonewton load is there. That means due to this 50 kilonewton, there should be some story moment. Then you have to calculate the story moment there by using the equation Q into H by 3. In that case, Q means it is the horizontal load, that means shear force acting on the particular column, and H means the height of the column, that Q into H by 3 will give the story moments. Then in this case, when you write this equation, that means the displacement contribution will be obtained by the displacement factor into the sum of the rotation contributions of that particular column plus the story moments if any. Then starting with this problem, you have to enter all these values into the Kani's table. You have to enter the fixed end moments and the rotation factor and the displacement factor. Then after writing all these values, we have to find out the sum of the fixed end moments. That means minus 187.5 plus 0, that is minus 187.5. You have to enter the sum of the fixed end moments inside this square. After this, you have to start with the displacement contribution. In this case, there is no story moment. So, you have to start with the displacement contribution as minus 3 by 4 into rotation contributions of the columns of the particular story. That means 0 plus here 0 plus 0, at the beginning it is 0, 0 plus 0 into minus 3 by 4, that is why here it is 0. After that, we have to find out the rotation contribution. That means sum of the fixed end moments plus the far end contributions into the rotation factor. In the case of CB, the sum of the fixed end moment, that means 12.5 plus 46.88 plus 0 into minus 1 by 4 will be here, into minus 1 by 4 will be here. Then after this first cycle, you have to start with the second cycle with the displacement contribution. That means the sum of the rotation contributions, that means 0 plus 46.88 plus 0 minus 39.85 into minus 3 by 4 will be here. Okay. Then in the case of rotation contribution, minus 187.5 plus 0 minus 39.5 minus 5.27, that value into minus 1 by 4 will be the second cycle value at here and at here. Similarly, you have to continue the Kani's method, Kani's distribution and Kani's iteration till the value same as in the previous one. After that, we have to find out the final end moments. Then how will you get the final end moments? The fixed end moment plus 2 into rotation contribution of that particular joint plus the far end rotation contribution plus the displacement contribution minus 16.1. In the case of columns, you have to consider these displacement contributions in the case of columns only. Then after getting the final moments, we can draw the S of D as well as BMD. Then in this problem, the only difference is we have to consider the story moment also. In this case, the story moment is 50. So it's when you find out the when you consider the displacement contribution, you have to consider the story moment also. That means in the first step itself, minus 3 by 4 into rotation contribution here is 0, at the beginning it is 0, at the beginning it is 0, at the beginning it is 0, plus story moment. That value into minus 3 by 4 will be here. Then story moment plus rotation contributions at here, at here, at here, at here. Then we will get a particular value, and that value into displacement contribution will, displacement factor will give the displacement contribution. Then you can find out the final moments. After that we can draw the bending moment diagram. Thank you.